Today we are going to discuss about deadlock prevention. So we can prevent the deadlock by limiting how requests can be made. So already we have discussed the characteristics of deadlock. So the four conditions: mutual exclusion, hold and wait, no preemption, and circular wait. All the four conditions have been occur in the system simultaneously. There is a deadlock. So what we need to do to prevent the deadlock means any one of the conditions should not happen in the system. Then we can prevent the deadlock. So the first one. So the deadlock prevention is prevent the deadlock by we are limiting how requests can be made. So we are limiting how requests can be made. So by limiting this, we are preventing the deadlock. So these four conditions, out of that four conditions, we need to make sure that any one condition should occur. So first one, the mutual exclusion. In the mutual exclusion, so at least one resource must be non-shareable. Then the second condition is all the shareable resources are not need to be a mutual exclusion. For example, read-only files. So if the resources are shareable, so you should not make it as a mutual exclusion. Then otherwise you don't at least one resources in the particular system should not be shareable with all the threads. The second one is the hold and wait. In hold and wait, while requesting the resource, it should not hold any resources. For example, consider the thread Ti, it requesting the resource Rj. While it is requesting the resource Rj, it should not hold any other resources. If there is a resource, it already holds some resources, it is not eligible to request the another resource. The third one is the no preemption. So if thread is requesting the resource, if it is not available, the thread should release all the resources which is already held by that resources. For example, consider the thread Ti is requesting the resource Rj. Already it is having the resource Ri, Rn and Rp. For example, you consider already it holding the three resources and requesting for resource Rj. If the resource Rj is currently not available, it might be allocated to some other resources. For example, you consider the Rj might be allocated to the assigned to the thread Tj. So that Rj is not available. So it won't wait anyway till the tj releases that resource rj. It should be in a wait state, the ta should be in a wait state, but it need to release all the resources which has been hold already, the rn, ri, rn, rp, these three resources might be released. So it won't, while the thread is in the waiting state, it should not hold any resources. Next one, the circular wait. So consider here, so for every resources we need to assign a unique integer. Okay, then consider we define a function f. So here the r tends to n, so the n is the integer, n is the integer number here. Okay, n is the integer number. Then, while the thread is requesting for resources, the resource which having the minimum real number. For example, if Ri is 1, Ri is assigned with 1, Rj is assigned with 2. So, if Rj is greater than Ri, the thread can first request the resource Ri. You may consider it the real numbers may be number of instances available for a particular instances. For example, the Ri is having the only one instance, the Rj is having the two instance. So first the thread need to request the resources which having the minimum instance. If it is available, it hold that, then it go on request the next maximum resource instance the resource has. So it go on request the RJ in that particular order. It need to request the resource. So consider now I show you the example. So consider there is a set of threads T0, Ti, etc. Tn. These are all the set of threads, and the Ti is waiting for Ri. So Ti is waiting for resource Ri, but the Ri is already hold. The Ri is already hold by the thread Ti plus 1. Okay, so that this is the first condition. Ti is waiting for thread Ri, resource Ri, but the resource Ri is already held by Ti plus 1. Like that, the Ti plus 1 is waiting for resource Ri plus 1. The Ri plus 1 is already held by the thread Ti plus 2 and so on. So it means that here you consider this one-to-one function. So f of Ri is less than that f of Ri plus 1, then it is for, so it is for all I. It means that f of R0 that is less than f of resource 1 is less than etc. f of Rn. Okay, and you consider then it is less than f of R0. So if you apply that transitivity rule here, so if we apply the trans transitivity rule here, so it means that f of R0 is less than f of R0. Here we have a here one f0 f of R0. Here we have one more f of R0. So it definitely will this condition will not happen. This is not true, right? So the circular bind won't happen at all. Okay. So for every resources you need to assign a integer value by using that one-to-one function. It might the integer number might be a number of resources number of instances associated with the particular resource. So always if the thread is requesting a n number of need the n number of resources. First, you need to request the resources which are having the minimum instance. So it has to go in that particular order. So by this way, we can avoid the circular wait. Thank you.